Hello children, today your lesson is Indices lesson, right? In last 2 years also you have learnt about this Indices lesson, right? Recall that memory. See, this is called the index notation. We know how to write a decimal, how to write a whole number, a fraction, likewise we know. And this is how we write indices, right? This is called the index notation. There is a base down, and for this top number is called the index, right? This means the number down, that means there is a number known as the base. That number is repeated how many times? 3 times. See, by expanded form I have written 2 to the power 3. 2 is multiplied by itself, this down number is multiplied by itself 3 times, and we can find the relevant value also by multiplying. 2 times 2 is 4, 4 times 2 is 8. See, and here I have given you 2 questions to expand, write in expanded form, right? See, only 1 3 can be seen, right? So 3 should be written once, multiply by x to the power 2, that means x should be repeated twice, and y to the power 3, y should be multiplied by itself 3 times. This is how we write in expanded form. See the next question, 5 to the power 2, 5 into 5 into here a into a into a. Then here children, you can simplify this a little. This is called the expanded form. If you are given a question to write in expanded form, you need to stop from here. But if you are going to find the value here, there is no any value for a, but here you can simplify a little. 25 a to the power 3. Likewise, even you can write. Okay, this form can be written in index notation also, remember that. Next, we will write in index notation this one. In expanded form you are given these 2 questions, we will write them in index notation. See, number 2 is repeated by itself 3 times, so I am writing 2 to the power 3. And here b is multiplied by itself 2 times, and what is the relationship between those two? Multiplication. And the next one, 7 can be seen only once, so no need to write 1 here as the index. Here I am writing just only 1 7, multiply by, here x is repeated in 2 different places. It doesn't matter, same letter, no. So we will take them together. X is repeated how many times in total? 3 times. And y is repeated 2 times. And remember this children, if there are letters like this, without this multiplication mark even you can write, okay? That means you can write this as 7 x to the power 3 y squared. This is also correct. Now children, in your review exercise, see the first question. See, you are given a table. A number is given. That number can be written in index notation, and after writing in index notation, we can identify the base and the index. Here the number is 8. Okay, it is written in index notation like this. So the base is 2, index is 3. Then children, you are given a number but no index notation, base, index, nothing is given. But children, you should know that we can write any number, a given number in index notation. You must divide it by what? Divide by prime numbers. You know prime numbers 2, 3, 5, 7, 11. Those are prime numbers, okay? So by prime numbers we must divide repeatedly downwards. So is this 9 divisible by 2? Start from the smallest one. As I told you, 2, 3, 5, 7, these are the prime numbers, no? 2 is the smallest. Start from the smallest. Is 9 divisible by 2? No, ne? So we will go to the next number, 3. Yes, it is divisible. 3 times 3 is 9. Again we will divide by 3, 1 will come. Until you get 1 as the answer, you need to divide the number repeatedly. So here you can write this as 3 to the power 2. Why? 3 is multiplied by itself to get 9. So this can be written as 3 squared. So the base is 3, index is 2. Next, a number is given and you are given the base there. If you are given a base, children, you must divide the relevant number 16 by what? By the base. If you are given a specific base for you, by that number only, by that base only you must divide the number repeatedly. So here by 2, 8. 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 1, 1. So this can be written as 2 to the power. How many times is it repeated? 4 times. Here I wrote. So what is the index? 4. Next, base is given, index is also given. So we can write it as 4 to the power 2 or 4 squared. So what must be the number then? According to this, 4 squared means 4 multiplied by 4. 4 times 4, 16. See, so using two different bases, we can write in two different ways, right? And the next one is 1000. Base is 10. In your mind, even you can get the answer here, 10 to the power 3. But here I will show you the division. 1000 can be divided by itself. 1000 divided by 10. 100. Again divide by 10. Again divide by 10. So this can be written as 10 to the power 3. But simply you can think like this. Base is 10. No. How many zeros can we see? 3. So power must be according to the number of zeros. So what is the index? 3. Now children, in review exercise second question, expand and write each of the following expressions as a product. By expanding, we need to write here 3 only once, x 2 times. Here 2 into p into p into q. Here 4 should be repeated 2 times, x should be repeated 3 times. Next, 5 should be repeated 2 times, x 2 times, y 2 times. This is how we expand the given index notations. Next one, write down each of the following numbers as a product of powers of which the bases are prime numbers. We are not given any specific base here. Children, remember that if you are given a specific base, by that number only we need to divide the given number, okay? But here they are telling us to write as a product of powers with prime bases. That means, can you remember earlier I explained by 2, 3, 5, 7 we need to divide in that way. So here I will write few prime numbers. 2, 3, 5, 7, 11, these are prime numbers. No, we will go to the first one. We will start from 2 every time. If the number is not divisible by 2, jump to the next number, okay? So we know that 20 is divisible by 2. So we will take 2 here. When we divide 20 by 2, 10 will come. Again we can say this is divisible by 2. Now 5 will come. Now is 5 divisible by 2? No. So I cannot write 2 here, okay? Then I jump to the next number 3. Is 5 divisible by 3? Not divisible, right? So I am jumping to the next number 5. Of course it is divisible by 5. So likewise in an order we need to divide, okay? Now we will write this 20 as a product of powers with prime bases, okay? So this 20 can be written as, firstly by expanded form I will write 2 into 2 into 5. Then I can write this as a product of powers here. 2 to the power 2 into 5. Here product of powers I wrote. Next 48. We will start dividing by 2 because by looking at the last digit we can see that this 48 is divisible by 2. So what will be the answer? 24. Again we will divide by 2. 12. Again by 2. 6. Now again by 2. 3. Now we can see that 3 is not a number divisible by 2. So we will jump to the next number 3. Yes, it's divisible by 3. Until you get 1 as the answer, you must divide repeatedly. Now this 48 can be written as 2 into 2 into 2 into 2 into 3. And now in index notation, how do we write as a product of powers? 2 to the power 4 into 3. Next 100. We know that 100 is divisible by 5 and 2 both. But children, don't start from 5. That is not the way. Of course, the same answer will come, but there is a way of getting an answer in mathematics, okay? So, usually from the smallest one only we need to start division, okay? So, by 2 I am dividing 50. Again by 2, 25. Now by 5. Again by 5. So, this 100 can be written as 2 into 2 into 5 into 5. So this can be written as 2 squared into 5 squared, product of powers. Next, 144 by 2, 72, 36, 18, 9, now by 3, huh? So this can be directly, I will write 2 to the power 1, 2, 3, 4 into 3 to the power 2. In the fourth question, you need to write 64 in index notation with base 2, with base 4 and with base 8. 3 different bases are given for the same numbers, for the same value. It's okay. We will divide by the given base. By 2 when we divide continuously, 32, 16, 8, 4, 2, 1. So we can write it as a in index notation now 1, 2, 3, 4, 5, 6. 6 times it is repeated. See. Next by 4. Base is 4 no, so by 4 we will divide. 1 inside 6, 1 4 is there. Then when we subtract 2 is coming, then we will divide 24 by 4. Then 16. Again we will divide by 4, not by 2, remember that. By the given base only you must divide. So it can be written as 4 to the power 3. Next by 8. So it can be written as 8 squared. Now children, we will learn about power of a product and product of powers. What is that? Sometimes you may be a question to write a power of a product as a product of powers, or else product of a power as a power of a product. See, you can remember like this. Power of a product, this is a power. See, forget about this inside one, this is a power. Power of what? A product. Inside this, inside the brackets, there can be a product. 2 times 3, 2 times a, likewise there can be a product. So remember, this is a power. See, forget about this for a moment. Power of what? Of a product. Okay, then what is this one? Product of powers. This is the product. Product of what? Product of powers. Okay, right. See, here you need to express the given powers. These are powers. See, in common now the power is there. Powers of what? Product. These are the products inside the brackets. These powers of product should be written as a product of powers. A product of powers. So I am right. That means this outside index can be applied for each and every number inside the brackets. Okay. So here I am writing 3 squared into 5 squared. Here I wrote as a product of powers. There can be 2 or more. Here this 5 can be applied to both the unknowns inside the brackets, and remember that between x and y the relationship is multiplication. There is a hidden product. So I am writing this as x to the power 5, y to the power 5. Without multiplication mark even can write, no problem. Here power is 3 no, so I can write it as a to the power 3, b cubed, c cubed. Next 2 to the power 7, p to the power 7, q to the power 7. Next 3 squared, x squared, 2 squared, a squared, b squared. Very easy, but remember that you need to remember these two. Okay, children, we will write this as a power of a product. As a power of a product we will write. You are given as a product of powers. Now we will write as a power of a product. We can see that the index is same here. Check whether the indices are same, otherwise we cannot write like that. Okay, in common I am taking the index out. So in the middle I can write 2 into 3. Bases can be written inside the brackets. Next, see the index. Index is same, right? So I am taking it out in common. So inside the brackets I am writing 3xy. You can put multiplication mark, no problem. Next, you are given just a number, not like earlier. Earlier in the numbers you are given, that means numbers are written in index notation, but here just a number is given, and this is in index notation already. See children, when you see this squared, the power 2, okay, 4 even can be written in index notation, right? 2 squared. 2 squared is 4. So this 4 can be written as 2 squared and this b squared. Now we can see the power index is common. 2b within brackets. Next, see the powers. That means you are given just a number with another terms in index notation. By looking at the indices only, we can decide it's the numbers index also. We know that 1000 can be written as 10 to the power 3. 3 zeros are there, no? X cubed, y cubed. So this can be written as 10xy within brackets. And out of the brackets, the index is 3. Next, when you see index is 2, 36 even can be written as 6 squared. 6 times 6, 36. A squared, b squared. So within brackets I am writing 6ab, index is 2. Now children, we will consider about the powers of negative integers. Powers of what? Negative integers. Just think 2 to the power 3, 3 to the power 2, 4 squared. All these are powers with positive integers. See, all these are positives, right? Positive integers are there. So you should know that powers of positive integers should be every time positive only. The value that we get should be a positive one, because there is no any mention about a negative here. So remember that any power of a positive integer, this can be even or odd, that means 1, 2, 3, 4, 5, 6, 7, any number of a positive integer should be every time positive. And even powers in a negative integer should be what as you think? It must be positive. I will write few examples also. If the power is an even number in a negative integer, answer should be a positive answer. And also if there is an odd power of a negative integer, answer should be negative. For an example, we will take this minus 2 to the power 4, minus 7 to the power 2. We can see these are negative integers and their powers are positive. Okay, powers or even powers with negative integers. And the examples for this we will see minus 2 to the power 3, minus 7 to the power 5. See, negative integers can be seen, and we can see an odd power. If there is an odd power of the negative integers, the answer should be negative. Now children, we will see how to obtain the previous results. See, within brackets you can see negative integers, right? In these negative integers I have put different powers. Even are there, odd numbers are there, in the order I have written. Okay, we will expand them and get the results. Minus 2 should be written only once. See, minus 2 only once, so it is minus. Next, this minus 2, what inside the bracket should be repeated how many times? 2 times. So here I am writing minus 2 multiplied by itself 2 times. See, signs separately, numbers separately multiply. Minus minus plus, 2 times 2, 4. It's plus 4. Next, this minus 2 should be repeated 3 times. So I am writing minus 2 into minus 2 into minus 2. 2 times 2, 4. 4 times 2, 8. See the signs, okay? Minus minus become plus. Plus minus becomes minus. Next, minus 2 into minus 2 into minus 2 into minus 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Now the signs. Minus minus became plus, no? From here plus came. You can continue like that also, but here from here I am taking minus minus become plus. Then this plus 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 only. Next, or else you can think like this: minus minus plus. plus minus minus, again minus minus plus. Next, minus 2 should be repeated 5 times. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. Now the powers, minus minus plus, minus minus plus. Now the minus is remaining, so the sign must be minus. Now say children, you can see that this is a negative answer, positive answer, negative answer, positive answer, negative answer. Likewise, it will continue. Now look at the powers there. Odd, even, odd, even, odd. So it's clear that children, if the power is an odd number in a negative integer, the result is also negative surely. And see, here also negative. Odd power, negative. Even power, positive. Even power, positive. But remember, in negative integers, okay, if this is positive, every time the result is positive. Right, now using the knowledge that we obtain, we will solve these. We will find the answers there. Now, no need to write by expanding like this, by putting minus sign, okay. See here, this is a negative integer. Power is an even number, so the result must be every time positive. So we can write it as 2 squared. The same result will come from here now. So 2 into 2 is what? 2 into 2 is 4. Next, negative integer, odd power. If it is an odd power, our answer should be a negative 1. But within brackets I am writing 5 to the power 3. So 5 into 5 into 5, 125. Next, 1 to the power 100 minus 1 to the power 100. In a negative integer, even power can be seen. When we multiply by 1 itself, the result is 1 every time. But our answer should be a positive answer, plus 1, because of this even. This is an odd number, and inside the brackets minus 1 can be seen. So surely our result must be minus 1. Next, 1 to the power, this is a positive integer now. So whatever this power, the result is 1 only. Next, even power. So answer must be a positive 1. So from 10 squared we get the same result. 10 into 10, 100. Next, odd no, odd power no. So I am writing minus mark front. 10 to the power 5. Here we can put 5 zeros to the number. So children, this is the end of this lesson. Hope that you understood indices lesson. And children, you can do the exercises in your textbook.